In today's class, we are going to revise the chapter Work and Energy. Question number 1. What is commercial unit of electrical energy? Also write its SI unit. And the part B of this question is write the relation between commercial unit and SI unit of electrical energy. The commercial unit of electrical energy is kilowatt hour, and that we are writing is as a symbol small k capital W small h, and which we also call 1 unit. Generally, we are having our electricity bill in the form of units. 1 unit equals to 1 kilowatt hour. And SI unit of electrical energy is joule, that we represent by small g. Part B. Now 1 kilowatt hour can be written as 1000 watt into 1 hour. Here we have converted this 1 kilowatt into 1000 watt. Now again, what is the unit of power? And power is actually the rate of doing work, in which we can write power equals to W upon T. W is work and T is time. Now the unit SI unit of work is joule and the SI unit of time is second. So we can write, in place of this watt, we can write 1 joule upon 1 second into, in place of this 1 hour, we can convert it into seconds. 1 hour, there are 60 minutes, and in those 60 minutes again we have to multiply 60 seconds, because each minute contains 60 seconds. So it will become 3,60,000 joules. And when we write it in the standard form, we can write it as 3.6 into 10 raised to 6 joules. So 1 kilowatt hour equals to 3.6 into 10 raised to 6 joules. Question number 2. State the type of energy transformation which takes place in a mixer grinder. Now here the mixer grinder is working with the help of electricity. So the electrical energy is transforming in the form of mechanical energy, which is rotating the grinder. Second is radio with a battery. Here battery means it's a combination of cells, and dry cells are filled with chemicals. So with the chemical energy we are getting electrical energy, and that electrical energy is converted into sound energy. Now comes solar water heater. As it is clear from the word solar, solar energy, which is coming to us in the form of sunlight, it is converted into heat energy. The last one is radio connected to supply line. Now supply line means electrical energy, and this electrical energy is converted into sound energy into a radio connected to a supply line. Question number 3. A rocket is moving up with a velocity v. If the velocity of this rocket is suddenly tripled, what will be the ratio of two kinetic energies? Let the initial velocity be v, and after the sudden change, final velocity of the rocket becomes v dash, and which is equal to 3 times the initial velocity. Then we can write the initial kinetic energy of the rocket as half mv square, and the final kinetic energy as half mv dash square. So kinetic energy final will be half m, and in place of this v dash we have to substitute 3v square. So it will become 9 half mv square. So when we are trying to find the ratio of these two kinetic energies, Ke initial upon Ke final, we get half mv square upon 9 half mv square. By cancelling these two with each other, we are getting 1 upon 9. So the kinetic energy initial to kinetic energy final, we are getting the ratio as 1:9. Next question. Calculate the work done in lifting 200 kg of mass through a vertical distance of 6 meter. Here we have to assume small g, that is acceleration due to gravity, is 10 meter per second square. Now work in lifting the mass is done against gravity. So we will write the formula of work as force into displacement. So force, which is given by mass into acceleration. M is the mass of the object, g is the acceleration due to gravity, and h is the height up to which that object has been raised up. So we can write W work done equals to 200 in place of mass, 10 in place of gravitational acceleration, and 6 meter is the height. So we are getting work done equals to 12,000 joule. State law of conservation of energy. The law of conservation of energy states that energy can neither be created nor destroyed. It can only be transformed from one form to another. What type of energy is there in water stored in a dam? Now, water stored in a dam is having potential energy due to its position. A bird sitting on a branch, since the bird is sitting, so it will have only potential energy due to its position. Now comes a bird flying in the sky. The bird is flying, that means it is in the motion, so it will have kinetic energy, and at the same time it is also at a position in the sky, so it will also have potential energy. Water flowing in a river, because of the motion of the water, that water will have kinetic energy. Illustrate the law of conservation of energy by showing the energy changes which occur when we draw a pendulum bob to one side and when we draw a pendulum bob to one side and allow it to oscillate. Here is a pendulum bob. We have drawn it up to this side, and when we leave it, it starts to oscillate. This is the maximum position up to which it can move or oscillate to and fro. It is the mean position of the bob. As we are drawing it here, its velocity is increasing and its height is increasing, due to which its potential energy is increasing. And when it starts moving on its own, at this point it stops for a second and again returns back to its mean position. So when it stops, its kinetic energy becomes zero and it will have only potential energy, and that will be the maximum potential energy here. Again it will come back to its mean position, and during this duration it will have both kinetic energy and potential energy, and the sum of these two energies will be a constant. That means one will be increasing and the another one will be decreasing. Here when it is coming to this direction, its kinetic energy is increasing and the potential energy is decreasing. At this point A, its potential energy is zero and the kinetic energy is maximum. Again it is going to the other direction, and as it is moving in the upward direction, its potential energy is increasing. At the same time the kinetic energy is decreasing, and at position C its potential energy will become maximum, and as it stops there for a fraction of second, its kinetic energy becomes zero here. Again from this position it starts to come back to its mean position. So again during this position its kinetic energy is increasing and the potential energy is decreasing. So this is how during this journey the sum of its kinetic energy and potential energy remains constant all the time.